Hello everyone. As part of this presentation, I am going to talk about salting technique in Spark. Salting technique is used to resolve data skew issues, and we will see what is the data skew and what are the contents of this presentation. So here are the contents of this presentation. We'll just quickly talk about what is the skew data and a salting overview and how does the salting works in Spark and what are the benefits of salting. What is a skewed data? So in a distributed systems like Spark, data is divided into partitions for parallel processing. So as we know, in the current world, the data is used in pretty much in every organization, in every system. So in order to process the data, we need to split the data into multiple nodes and worker nodes, and so we need to execute them. you know uh, the expectation here is like each partition, when we split the data into each partition, the expectation is that we will be equally distribute the data so that each partition more or less executes the same amount of time and returns the data back to the um, either client or whoever issues that request. But in some situations, when the data is partitioned based on a certain key, so the data itself might not be equally distributed because of certain scenarios. When the data is not equally distributed, when one partition having a large amount of data over the other one, so it would cause the data skew. So what it means that some partitions executes very fast, some partitions would take a lot of time, and also it's not just about time. One partition will not use available resources completely, but whereas the other partition will require more resources. And similarly, when internally it process, it goes to it causes the disk spill, so which means that there would be a lot of reading back and forth from the disk, so that would cause a heavy load on the network, and as well as slows the process because every time you need to go and read the data from the disk. So this is the data skew, and this is the problem when the data skew occurs, and how to solve the data skew. So one of the techniques in Spark is salting. So salting is the technique to resolve the data skew. Salting involves adding a random component or salt to the data distribute evenly across all partitions. So just to put it in a simple words, let's say you have a member ID on which you are either doing aggregation or join. So that member, under one partition may have many members, and in other partitions you have less members. In order to equally distribute the high density of members, we just add one additional column that is called salt. So we will explain the salt technique with taking one example. We will see in the next coming slides. So how does salt works in Spark? So first, before we apply the salt technique, so we identify the skewed key. So as I mentioned, so the data for one given key, the data will be very high, for the other ones the less. So we need to identify which key is causing the data skew. So the first step is to identify the key causing the data skews. This is usually the key with a disproportionately high frequency. So how do we identify? We can write a simple group by query based on that group and count based on the key that we are using, either in joins or aggregations. That itself can give us the counts at upfront. Okay, based on that key, the distribution would happen over the partitions. We can understand if one partition having or the other. So the next step is, once we identify, add a random salt to the skewed. So in this case, we can add, let's say, if we want to partition within the skewed ID, if we want a skewed key, if we want to partition it, so we can add that random number. So it will split the data skewed key into 5. This is done by appending a random number to the key. The salted key helps in distribute data more evenly across platform partitions. So once the salt is added, so we will repartition the data, and this will is repartition will redistribute the data across the partitions. So finally, what we do, we join the data. The data is joined based on the salted key. So earlier we were joining based on only one key. Now we add the salted key as well along in the joins. So that would obviously, once we join original key along with the salted key, that would distribute. So let me explain that with an example. So here is the sample code that explains how the data skew could happen and how we can resolve. So in this simple code, so first here we are creating the list skewed underscore data. So where A is we are creating 1000, and B we are creating only 100, C 10, and D 1. So we are preparing the data frame. So based on this key, and then so if you look into the slide here, so this is how the key and count. A is 1000, B is 100, D 1, C 10. So this is how the data is created here. So as we know, since A, B, C, D are the keys, if we process this data, A will go into one partition, B will go into another partition, C and D. So but whereas if you look at A, so A is having a lot of data, so it would take a lot of time. Here we can identify that A is skewed here. So this is the data frame that we created here with the help count. So we will know that which key is having a lot of data. And once we identified the skewed key here, in the next step we are identifying skewed key. So we are using this count order by and ascending. So we are taking first of, in the sense what we are doing is we are writing the group by count, and so whichever is the key, whichever is comes first, that we identified as the key. So here in this case A is the skewed key. So now next step what we are doing is we are adding a random salt to the skewed key. So now only we have A is the key, and we are adding. So let's say in case if you want to add 10 partitions within that skew, so we can supply the 10. And if we supply the 10, so this is how it would look like. So you have A and you have the number 1. Or if you can here in this case we distribute into 20, but you can even give 10, so that that A key will be split into 10. Okay, so that's how you add the salt key. So once that is done, again you repartition based on the salt key. So once that is done, then if you do the group by here, so obviously it will show for a given key one row per each partition. Okay, so this is the sample output. So the bottom line here is you have a column A and you are adding a salt. So let's say if you want to divide it into 5 partitions, you will specify 5 1 2 5. So A1, A2, A3, A4, A5. So that would be rather than going A alone into one partition, after salting, it would go into 5 partitions. So that the A will not cause a data skew. So, and this way we will be executing all the partitions very efficiently and very fast with less resources. So finally, what are the benefits of salting? So we already covered benefits while talking about salting technique. Here are a few things. Improved performance. So by ensuring a more balanced distribution of data, salting can significantly improve the performance of Spark jobs. So as we discussed, when one partition having a lot of data, other is having less. So it would cause the imbalance, but when we balance it using the salting technique, so it significantly improves the performance of Spark jobs. And better resource utilization. So salting helps in better utilization of resources by preventing certain tasks from becoming bottlenecks. So as we said, even like out of four keys, three keys are executed fast, but if the fourth key is not, or fourth partition is not completed, so it would obviously, the end client would wait for this one to complete. So the data secured partition become a bottleneck. So, and moreover it requires a lot of resources, whereas other partitions will be under utilization of the resources. To balance out the resources, salting technique will be used, and it basically it makes the resource utilization effective. Scalability. So salting allows Spark to handle large data sets by mitigating the effects of data skewness. So again, this is we keep talking about the same thing. The large data sets can be broken into equal partitions, and that ensures that you are causing less performance. I mean issues. So it makes jobs execute faster with less resources. Yeah. So yeah, this is all about salting technique in Spark. Yeah, thank you for listening.